Hello, hello again. Can you hear me all right? Sweet. Okay.
Yep, sounds good to me.
Okay, excellent. All right, so workshop number 2 of today, somewhat of a similar format to earlier, where the idea is I'm going to do a little bit of a talk introducing what data-driven DSLs mean, a little bit of kind of the history or why they're good, and then we're going to then give you guys probably about 45 minutes to an hour to try to work on a little design of your own. And then after that, we'll kind of come back together and talk through and present some of the designs that you guys have submitted. We might ask you some questions about them. Yeah, we'll see. Basically, yeah, we'll do a little bit of a talk. You guys are going to work on some designs, and then we'll review them. Cool. And yeah, if you have questions and things as I go, I'm going to attempt to be able to like answer during the talk. And also I'm looking at the Slack and I'm also looking at the Zoom. So we'll see how things go. Cool. And I will start by sharing my screen, and we'll kind of start by introducing data-driven DSLs. Sweet. Okay, so, modern programming languages, and when we program, we end up using a lot of DSLs, and we might not even notice it, right? And so when we say DSLs, we mean kind of domain-specific languages, and perhaps easiest is to kind of just mention some examples, right? So in Clojure, even like you have regex, and so almost every language has regex, and it has basically this micro language built in for doing a specific task, and the syntax you use is completely different for interacting with that like regex interpreter. Or other things like string.format. Like if you're formatting a string, then there's a certain little micro language used to dictate like how you want to format that string in terms of dealing with numbers and like concatenating with things like that. There's also parsing dates. Has a little micro language of how you can write the pattern for how you want a date converted into a string. Or another example in Clojure is destructuring. Right, the syntax for destructuring might be a little different in each language, and it's basically like a little micro language of slightly different behavior in how that works. And then the most kind of like common external thing to languages when people think of DSLs are typically query languages, like SQL, right? It's basically a language, a pretty micro language designed just for the specific purpose of querying a relational database. And what we typically see with like all DSLs is that they're meant to be for like some small common problem, and then the language is done in a way that's like not like a Turing complete, like a general kind of purpose language. And this kind of brings me to this idea that there's a certain like bargain that we make when we're using DSLs or when we're designing and working with DSLs. DSLs kind of introduce new behavior to our kind of program and give us more power, like being able to query a database and all that involves, or doing regex and doing search. But that power comes at the cost of slightly more complexity, right? Because now you have new behavior and you have to have a new mental model. Like when you're working with regex, right? Like the regex subsystem is this completely new, different kind of machine that you're working with compared to, let's say, Clojure. On the outside. And so, we want to avoid in general just adding more and more complexity, like if adding more and more features to a language, because that adds more complexity because every feature can interact with every feature in some other way, and our mental model of the language then tends to have to like grow and grow and grow. So the reason that DSLs kind of survive is because they're able to kind of bound and limit the amount of complexity that they introduce. And they do that often by making a very clear boundary of like what is like your host language and then what is like this sub-problem. And so like, for example, when you use regex, you know that, when you're running like rematches or refind, you're not having any side effects or anything else going on. Or when you're using a database, you kind of mentally separate that like you're sending a query to some other system. But the moment that like that database is built in and fully touchable by other parts of your system, it can kind of get confusing. And so separation is an important part of DSLs, is trying to like separate the interface. And the other thing is we kind of limit the vocabulary and the syntax of the language. So very rarely do you see DSLs that are Turing complete. Very rarely do you see DSLs that allow you to like come up with like infinite abstractions. And that's important. Like we want limited languages that are both like functionally simpler and syntactically simpler, because otherwise we'd just be getting like, we'd be getting more power, but also perhaps at like an n squared cost of more complexity added to like our kind of when working with the program. So that's kind of like the idea of the bargain of DSLs. You get more power, you get more complexity, but that complexity is bounded thanks primarily to clean separation of the interface, where it's not leaking out into the rest of your program, and some limited limited expressiveness of that sub-language. And when we kind of, I've been thinking about data-driven DSLs and DSLs in general for a while, and I've kind of thought like I kind of categorize them into three different categories. And the way that things were done back in the day, because the percentage of people programming was much smaller, and anybody who was programming was like pretty much a hardcore programmer. Let's say when I'm talking about like the 50s and the 60s. And so whenever you wanted to come up with like some new separate functionality, what would you do? You just, you'd write a completely new language from scratch. And so you'd like come up with a custom grammar and so you'd come up with a custom grammar and just write a parser for it. So I have a question coming in from Galen. When we're talking about data-driven DSLs in this talk, are we considering DSLs that leverage Clojure data structures, or I wrote my own string syntax that I'd write a parser for? So I'm just going to introduce data-driven in a moment, but basically, yeah, data-driven is more about leveraging data structures rather than string syntax, like custom string syntax. But so coming back to this idea of like the first type of DSL, which are just like, you write your own custom language. So we'll take, in this example, we'll take various database query languages. And so SQL has its own, completely own language. It's declarative and it's somewhat limited. I mean, but SQL is actually like a composition of like 4 different like sub-languages. But at least for querying, it's pretty declarative. It's somewhat pretty simple. I mean, there are some weird interactions. It's definitely not completely trivial, but it is like a custom syntax. And when you use it from other languages, typically what you've had to do is just basically pass a string to some library, and that string gets passed off as a query. And then occasionally you might need to have a safe way of injecting values into that query. So those are kind of the first category, which are the custom syntax ones. And so the interpreter and the system under the hood is consuming basically a string syntax. And you have a full kind of grammar working behind the scenes. In the 90s, I think, at some point, people started introducing kind of a different kind of DSL, which are kind of called Fluent APIs. And that's basically trying to make rich DSLs within a language. So for example, here I'll talk about like, this is RethinkDB's API for working with the database. And it's like, this is how you do it. So they don't take strings. Instead, they give you a library of various functions that you can chain together, or there might be various ways that, like, chaining is one of the main ways that Fluent APIs are designed, but they can do other things. We'll talk about some other examples. But basically, instead of having a grammar, a custom grammar, you instead now have that like interpreter it's consuming constructs from the language. So, and you might have functions and things that you compose together, which is it's kind of nice. Like you get to now you get to kind of stay in your language. It does mean that like if you want to have multiple versions of a given, let's say, database talking to different languages, they might have to then design a different API for each language. So you might have the Ruby version of the Rethink API or the the JavaScript one. But it's certainly a thing. Very common, like, I also put in this class a lot of the kind of macro-based ones. So Lisp had a lot of these sorts of libraries, like Common Lisp especially, but even Clojure in the early days. So like Core Async, for example, is like a Fluent API. It's an extension to the Clojure language, effectively, that changes the behavior, and it has like basically it's a different kind of engine that you're writing code on when you're using core.async. With macros, you can do basically any sort of stuff, and you tend to do a lot of meta programming. And so you can basically come up with your completely own independent sub-languages within your host language. And another one is like another example is the Ruby community. The Ruby community really loves meta programming. And so a lot of the libraries that they build tend to fall into DSLs under this second category, to the point where, like, you take something like Rails, and you can basically think of Rails as a collection of various DSLs that they've designed, glued together, where the underlying kind of interpreter is receiving like classes and Ruby data structures and methods, and that is like the input to the interpreter under the hood. So instead of just passing strings, you're now constructing various things in perhaps weird ways that Ruby doesn't like. You're writing Ruby syntax, but you're not really doing what you would be doing with plain Ruby. You're only writing things for the purpose of handing it off to some library. I'm thinking of like the router in Rails, or just like how active record works. But even things like rspec, which is one of the Ruby libraries, and how it does like mocks and stubs, and it uses a lot of monkey patching, creating and generating classes and methods at runtime. And so, and that's kind of how it achieves like a nice interface while staying like within the language. But it certainly does a lot of kind of magic that we might call it. So basically, in context, so like if our custom text grammars were consuming strings, our kind of Fluent API type DSLs, they basically have like live access to the VM, and they're consuming language constructs. And then in Clojure, we've been starting to see this thing, which has been called like data-driven APIs. And I've kind of noticed this, and then I've been kind of following kind of this trend, and it's been kind of really interesting to see, because it's not really happening much outside of other ecosystems. Now, I can't really talk, too much outside of, I know Clojure, I kind of pay attention a bit to the JavaScript and the Ruby ecosystems. And so maybe, if you guys, like, I wouldn't be surprised if you guys were like, yeah, I'm actually in Haskell. But mostly I see data-driven being talked about in Clojure. And what data-driven APIs try to do is basically they just have libraries take data structures and plain data structures. So like not classes, not methods, just like the simplest form that a language typically supports. So in Clojure, that would basically be EDN. But if we were doing kind of data-driven stuff for JavaScript, we'd probably be doing JSON. And because JSON is kind of universal, you might think that like even like Ruby or some other languages, data-driven might just mean JSON. And yeah, and so the why is this better or different? Well, before I kind of go into that, I'll kind of give a few more examples. So here we kind of see examples of like what the syntax might look like for query languages, but I'm going to go through two quickly to kind of also showcase the difference of like what data-driven is versus these other ones. So if we take regex, for example, the kind of Perl style regex, which is common in pretty much every single language, it looks kind of like what we see on the left. But there's a Clojure library called Regal, which is a data-driven regex syntax, where that looks kind of like on the right. And these two things are equivalent, but basically you use data structures consisting of like keywords, vectors, characters, and strings, and you use those to represent what you want. And we'll talk about why that is better, but this is kind of like an example of what how those two things are different. And you might, ask yourself, like, which one of these, people tend to call regex write-only. Regexes are write-only and you can't read them. And it's also, if you want to like programmatically generate a regex, you're basically doing string concatenation or things like that in most languages. Whereas when you're working with like a data structure-based approach, you tend to have like much kind of richer ways of manipulating effectively what's like an abstract syntax tree. But it's kind of not easy to write as a human being, easy to programmatically generate, and pretty reasonable to manipulate. So I'll kind of quickly also look at another example in the case of routing. So we saw in Clojure, one of the most popular routing libraries on the server side for many, many years was Composure. And I would classify Composure as this like Fluent DSL, because it's effectively using macros, which are an in-language construct, to generate, at the end of the day, a single function for your handler. And we contrast this with Rated from Medicine, which is one of many. There's a number of like routing solutions that are data-driven, but it's the one that kind of I like and I tend to use. And we kind of see, effectively it's all the same stuff, but the Rated under the hood is going to it's going to be receiving just this kind of like array of arrays and maps and maybe references to functions. You could probably put inline functions as well. But it's much easier to like code generate this, the Rated style. And it's also a lot easier to inspect later. Like you could walk over this data structure, you can manipulate it if you need to, you can inject middleware if you needed to. Whereas with Composure, one of the challenges was that like effectively all you get at the top level is some function and you can't dig into that function. Like it just generates a function for you and what are you gonna do? You can't like post manipulate it in any way. And then people have kind of, the way the solution then is to like, then wrap it in middleware or wrap, and then other people have introduced other routing patterns. But, part of basically the problem with these kind of like Fluent DSLs sometimes, and especially ones that are macro-based, is that they make things opaque and impossible to kind of like dig into after the fact. And we kind of like metaprogramming is sometimes really powerful. And when I say metaprogramming, I mean like being able to like use the things that we've defined and then at runtime be able to like manipulate them in various ways. So let's kind of go back to this question of why is data kind of driven better? And looking at our three kinds of styles, with the custom syntax, with the custom text grammar, we get a nice separation of concerns, right? We know that, when we pass off a query to the database, it's going to do something and it's going to return a value, nothing else is going on. But with like the Fluent API, and especially with like macros and things, in theory, anything could be happening. Like some of these things like might be manipulating various things. Like there's, anything that's available to the language, these functions might be doing under the hood. And sometimes those libraries do abuse that, especially testing libraries. Testing libraries tend to totally like manipulate and modify the objects that you give to them. And that basically adds mentally to the complexity of having to use them. And that's why they tend to be only used in like limited contexts. And so with, same thing with like core async. When using core async, you tend to use it in a limited way because it has a, if you're not careful with it, it has a tendency of just like infecting your entire application. And now you not only have to have your Clojure data, like Clojure mental model, you also have to think what core async adds. And so custom grammars, nice separation, and they're pretty much as terse, meaning as short as they can probably be if they're well designed, whereas some of the other ones tend to sometimes be longer. But kind of one of the challenges with custom ones is that you then have to deal with like injection, because like the only way to manipulate them is string manipulation. And if you do string manipulation incorrectly, because it's an interpreter, there's a danger of injection. With Fluent APIs, that tends to be, the injection issue tends to be a little bit less of a problem. It's still sometimes possible, but in general, a well-designed one will tend to escape things because you're passing in parameters directly. But I would argue that Fluent APIs, so this middle group, has broken kind of the compact, that bargain that I said initially, like because they add complexity in a kind of unbounded way. So they give you more power, but they also tend to just be completely additive. And a lot of times they're not well encapsulated and opaque. And in general, just like I feel like they tend to add complexity unless they're like really, really particularly well designed. And so I kind of think of this, like the analogy is what I say is like this is this tragedy of adding more and more features to a language. When you take a look at, let's say, JavaScript, C++, and Java, they've been like adding and adding and adding more and more syntax to the language. And with every little addition, there's kind of like a, a super linear, like an n squared increase in complexity, because now you're like, well, how does this destructuring syntax interact with this other feature of the syntax, with this other feature of the syntax? And it just, they keep making the language and the virtual machine, and therefore the mental model that I have to have in my head as I'm working on it, they kind of keep making it bigger and bigger and bigger and bigger. And that's not great. Now, the community then ends up having to do things like, say like the good parts, like, okay, these are old features, we ignore these completely, or these are not allowed in our code because they add to the complexity. And then you have, as a contrast to that, you have Clojure, which effectively tends to extend itself primarily via libraries that are done in a functional way. And functional programming tends to kind of limit the growth of complexity because of how it kind of encapsulates. You kind of know if a function is pure, that it's not going to interact and modify things. But there are libraries, like I mentioned core async a few times, that that do kind of just purely add complexity, and so they have to kind of be used sparingly, just like with, and so like macros in general. We in Clojure we now have this culture of like use them sparingly and judiciously, because they tend to just increase your mental model and your cognitive load as you're working with them. And so with the introduction of like this concept of data-driven APIs, I think it's kind of an attempt by people to kind of have their cake and eat it too. Can we have the same kind of limited complexity growth with our custom grammars, but also still have the niceness of being able to like generate it with code and manipulate our syntax without having to resort to string manipulation? So I think that's basically the idea there. Like, let's still have a simple grammar, because effectively we're using data structures. And the nice thing about data structures versus just like general language constructs is that, data structures are much, much simpler. You could say, oh, well, code is data, strings are data, data structures are data. But, yes, all of these things are data, but not all data is equal in terms of complexity. I know that when I have a map with a bunch of keywords and vectors and lists, that doesn't do anything. It's just like describing stuff, but there's no inherent behavior. Once I start mixing in macros and functions, anything could happen. There's variables, and like there's like a very different mental model. And so data-driven APIs basically still give us limited expressiveness, but in a way that makes it easy to write as a human being, manipulate programmatically, compose from various, if you have, perhaps on a query, you have different subparts of a query that you're able to kind of lump together in a quite easy way, and to just generally like generate with code or translate from one type of representation to another. And so I think this is why a lot of people like them, because they both kind of give us that full power of like whatever DSL interpreter that we're designing, and still give us an interface that's better than just strings and string concatenation. So, when, what are some downsides to data-driven? I think, it can definitely be more verbose in certain cases, and certain things are much harder to do, especially when you have like multiple references to things. And so there's definitely certain cases where it just doesn't make sense. Especially like if your problem that you're trying to solve is like imperative in nature, then using like a declarative API is just like asking for trouble. And so my favorite example of this is Ansible. So Ansible is like a tool for like deploying to servers and things and writing like deploy scripts. And they had a really great idea and a really terrible idea that they kind of put together. The great idea was, hey, let's generate this basically like community curated collection of idempotent functions. Basically, like so like if you want to, let's say, create a file on a server, you just have to say create file, and if it already exists, that function is smart enough not to do anything. So idempotent functions, great, fantastic. But then the terrible idea, in my opinion, was let's have this language be written in YAML. And so now you have this like incredibly verbose, incredibly tedious, basically syntax that under the hood is still running on like an imperative system. Like I dream of someone basically creating a Clojure version of Ansible where you still just have access to functions and things, but all the functions, you just basically have a collection of functions that are idempotent that are related to that domain deploying to servers. Anyway, and another example of like things that sometimes don't work out is actually like SQL. So like, on my screen, right, we see there's this kind of data-driven way at the bottom of writing SQL, but SQL, the language, is actually quite complex. Like, if you want to do the basic stuff, yes, it's easy to kind of write this data wrapper around it. But if you actually want to fully make use of like everything that's in Postgres these days, then usually these kind of APIs on top fall short. So for example, at our company, we tend to use YesQL, which is just like a really light wrapper around SQL, because we find that SQL is sufficiently complex that it doesn't make sense to kind of try to abstract over. But in a lot of other cases, like routing and things like that, it probably does make sense. So I'm going to spend just a few more minutes just walking through a few quick examples, and that you guys can look at later. I'll post these slides. So we have like we can compare like JSX, which is how you do stuff in React, with reagent. JSX is basically a custom syntax, and they've had to like basically create another compiler and do it in the compile stage to be able to like change this into actual code. And you end up having to do some like really, really weird things in order to like interoperate between the JSX code and the JavaScript code. And you contrast that with like reagent, which makes it like, which is just data structures, and it's like it's an order of magnitude easier and simpler to like compose and manipulate effectively HTML. Another example is, for example, with styling. So CSS is a custom syntax, and then there's additional like extensions to it, things like Sass. But it's it's only meant to be human writable, and it's non-trivial if you wanted to like generate code to create Sass. In the general case, like you might be able to do it in some small special cases and by doing string manipulation, but then you contrast that with something like Garden, which is a like Clojure hiccup for CSS, and we very frequently will do like for loops in our CSS to like generate a whole bunch of repetitive code. Another example, and this one is sad to see because this is quite recent, and you'd think that there's been a bunch of data-driven examples already existing at this time, and so that's the design of GraphQL. Like GraphQL is again a custom syntax for querying graph databases, and it's pretty Spartan. Although this is a very simple example, there's a lot more that it can do, but it's so hard to like programmatically generate. And in contrast, we have in the Clojure community, people have kind of created what they now are calling Equal, which is EDN query language, which again is data-driven and absolutely kind of trivial to manipulate and generate at runtime or like just programmatically. So, and then as the final example, I wanted to show, and this is purely within the Clojure community, the difference, for example, between spec as it is in Clojure and Molly. And so Medicine has, Medicine did rate it, and Molly and a few other languages, and they're definitely like one of the driving forces behind this data-driven train. And so they found, for example, spec is cool and nice, but it is a Fluent API, right? Because it's using macros and constructs within the language to create and compose specs. But when when Medicine was trying to use spec, let's say on the front end to do various validations or generate forms or do coercion, they were having a challenge because it's so hard to like, given a bunch of specs, to like walk over them and manipulate them in various ways. Like it didn't expose enough to be able to do things. Now they did hack around it a lot, and spec tools is like amazing that it actually works. So spec tools is a bunch of like libraries that Medicine made on top of spec to do various useful things. But they basically gave up at some point and said, you know what, like spec just makes this really, really hard. And so we're just going to design something of our own from scratch. And the result is kind of right now is Molly, where it is just a pure data-driven approach to creating specifications. Now the syntax looks a little bit different and it takes a little bit of getting used to, but I personally use this a bit now, and it's so much easier to now use this programmatically and to do like meta programming things, to be able to like take a spec and use it for coercion, or manipulate it slightly and use it for coercion, or take a spec and generate forms from it automatically. so on and so forth. So almost done my intro here. Why don't we see this in other ecosystems? Like we see a little bit, like JSON schema and the surrounding ecosystem tends to be doing some interesting things. Vega, which is like an example of a data-driven language for describing graphs in a declarative way. So there's little inklings of it, but not as much as I would have imagined given the benefits of data-driven stuff. And I think the reasons why are, one, in Clojure, Eden is so much nicer to work with in JSON because you have like so many different more types. You have dates, UIDs, symbols, you have sets, you have comments. So those extensions like make it much nicer to actually like model stuff than with JSON. Another thing is that in Clojure, like we're used to metaprogramming. Like there's a heritage of using macros and just like manipulating the runtime. And so there's been kind of a natural transition to do that, but in a more pure way. And also Clojure just makes it so easy to manipulate data, right? Like we just do that all the time as a matter of course. And so it's, using data as the basis of which like to build our APIs kind of makes sense because it's so easy. Whereas in other languages, it's kind of tedious. Like especially in typed languages, like just writing a parser you have to like now write a parser for a specific kind of JSON data structure in order for be able to like receive JSON. And finally, like how can you actually like apply this to your day-to-day? I'll give a few examples of like things that we have done at our company where they're like micro APIs that we've designed. Because I mean, I think like in general, actually like Rails, for example, has shown that like web applications, you can kind of break down any web application into like 5 or 6 DSLs. You come up with 5 or 6 DSLs, one for like routing, one for, UI stuff, one for like connected to the database, et cetera, and you've got yourself a stack. Now, doing it the Ruby way is a lot. It feels like magic in a bad way. It's like it's all like hidden behavior. So perhaps there's better ways. And so what we've been doing at our company is we've basically occasionally been creating these little DSLs or little libraries that are done in a data-driven style to solve common problems that we encounter. So one of those, for example, has been like managing pages and the concept of pages both on the client and the server side. And so we created like basically like a simple description of what a page is. Oops, I need to go back. And then we use these on the client side to take care of routing in like a React application, as well as like dispatching events and things and hooking up to the kind of corresponding top level view. So it's kind of similar to React Router in a way, but React Router is like a React only thing and it uses React as a Fluent API of like designing it. Whereas our thing is just like, it's just keys, it's just keywords and strings and functions. And it automatically does like coercion under the hood because we're using rated. And on the server side, we can use it to basically decide which things can be like server side rendered, like given a request, which pages are valid and which ones we can server side render. Another micro example is before rated was a thing, we were kind of also getting frustrated with Composure. And so we designed our own little data-driven API. Now it's probably not like, it's simpler in some ways than Rated, but also less powerful. And Rated is actually like super, super efficient and fast and magical. But this API for just like defining routes was literally just like this, vector of vectors and where we would just have like get some string and then a request handler and optionally a list of middleware to apply. And that we still use in a bunch of things today because it's a pretty nice way of doing things. And it's kind of easy to manipulate and inject middleware and manipulate it. And this is kind of similar to how Pedestal has like one representation that you can use that looks similar to this. And finally, another one that we've been working on is, and we've kind of extracted this into a little project last year, which we call Tada. And effectively, it's taking this idea that like, there's a whole bunch of things that we could probably represent on a system where we're like, if we were to model the problem domain, like for example, if we were to model the various entities involved with, let's say, Mali, and the various kind of like commands and queries that can be performed on a system, if we could do all these things in a data-driven way, could we then just derive our actual like HTTP handlers and our front-end AJAX handlers from these declarative data-driven representations? So we have, for example, here one kind of command that we define, which has some ID, has some parameters that will be used to then coerce and validate data that's coming in. There's a function that represents various preconditions that must be met by the system, and various then side effects that would happen if everything was met. So this data structure is then used, for example, in an HTTP handler, where it will first filter any data that's coming in to make sure that it matches that pattern, deny anything that doesn't for security reasons, coerce things that do, so coerce strings to like integers or to UUIDs. Then it will run the conditions, and if one of these conditions don't pass, then it will like automatically give the kind of correct, like, is it a 400 or a 500 or a 503 with an error. And if anything does pass, then it returns a side effect, then it performs that side effect. So we found that that's pretty useful, and we're kind of still tweaking and iterating and working on Tada, that library, and trying to see how far we can push that data-driven approach. So are any of these open source? So Tada is, I can share a link to that. Just give me a second.
I can get the link, you keep going.
But yeah, this is actually, like, this is a nice, like, here you go. So this one is Tada. And there's a talk in the resources of the README that I gave a talk at Clojure last year about the beginnings of Tada. Anyhow, that's actually all I wanted to say about data-driven DSLs. I know that took quite a bit of time. And so the task now for you guys, and so let's maybe even assign like 45 minutes for this. So we'll go until like 15 after, is to take a look at the README that we've prepared for you. And your task basically is going to be to choose one of these sub-problems that we've kind of pre-identified for you. Or if you have something on the top of your mind that you really want to do, go ahead. But we kind of prepared like a list of 20 that we think are appropriate for today, so that you don't spend 20 minutes thinking about what you want to do. And so your task and goal, what I'd like you guys to attempt is basically think of what a data-driven representation for some subdomain might be. So let's say one of them is music. How might you represent music in a data-driven Clojure EDN style way for the purpose of feeding into something that plays the music, or then in a way so that it can be manipulated and then rendered as sheet music or whatever. I mean, you guys can go wild in terms of what you think of the purpose. Like, it's up to you to decide what the purpose of your little micro design is going to be. But just to clarify, the goal is not to implement it, it's just to design like the interface, like design what the, you know, if I had a music library thing that could play music, or it could render a data structure as sheet music, what would that data structure look like? What would the function, what would be some useful functions to work with it? So that is the task for you guys over the next 45 minutes. It's going to be, yeah, go to that, go to the README. I'll try to, I cannot change the URL, but I'm going to change what I'm sharing. But basically, yeah, like read through there. We have a bunch of like reflection questions there that might also be useful in terms of like things to think about when you're designing. But don't worry too much. Think of this is like a quick little design sprint. You have 45 minutes, do the best that you can to come up with a little data-driven design for a specific use case. And then just like in this morning's workshop, there's a spreadsheet for you to kind of submit your designs. And so the goal for you is to, like, after you've kind of come up with the design, is just to create like a little micro README of just like including 1 or 2 examples of what that syntax might look like. And then we'll just kind of share them and briefly comment and talk about them. Like, I'm no expert on data-driven design. I think it's actually probably really, really hard to do it nicely. And things like rate it are, you know, non-trivial things to like come up with to make a nice design. And so I assume that, you know, the first stab that of anybody doing this kind of stuff, it will kind of look kind of fugly and like just might be not great, but let's do it. Let's design some data-driven DSLs. So over the next 45 minutes, go ahead and kind of work on that. If you have questions, we'll be here. We can kind of bounce back thoughts and things. But yeah, let's try this. Okie dokie. Yeah, and I'm sorry for sneaking in a talk. I was hoping that it would be like 10 minutes, but as things, things always go over time. But I wanted to give people kind of a bit of a context and introduction.
Yeah, no worries about your sneaky talk, though. It was really good content.
And I guess in the meantime, as you guys are working on things, if you have any like general questions about data-driven or things you have in mind based on the talk, we can spend this 45 minutes you guys working and also doing a bit of a Q&A on some data-driven design, data-driven DSLs. And in terms of where do we put our solutions, we just have a spreadsheet where we can just post links. So ideally, you can make a gist on GitHub or just push a repository, clone and fork in repository. We have a template in the repo of like, here's a README. And again, you don't have to like really try to just like more do some design thinking. How would this interface need to work? Yeah, we'll see what happens. Okay, folks, we've got a number of submissions coming in, so I think, yeah, feel free to push and try to add yours to the sheet. But I think we'll start kind of just sharing and discussing some of them, just in the interest of time, because there are so far like 8 of them, and so I take a long time to talk about things, so I'll try to keep it quick. But we have half an hour left, so let's get started. James, are you here as well?
Yep, I'm here. Do you want me to
Sure,
share,
yeah,
or
do
you want to
go ahead and screen share?
Okay, I think I have them all just pulled up already here. So I can just kind of start talking. See if I do it like this. Is this going to work? Oh, God. Okay, hopefully people can see my screen here. So the first one we have, I'm just kind of going through the spreadsheet top down, is this DSL for writing a graph. So representing like edges and the vertices. This is for something like a dot or a graph is for being able to output like a visual graph, I believe. So kind of an initial thing, which as I think we were talking in the Slack, is kind of just a way of representing a graph. And there's some iteration on this in the comments. So we start by essentially just saying like vertices, and then having like under each vertex, it would have represented by a key, and then like a map where it could have some like extra metadata on it, like the name or something. And we have edges, which say like from to, an optional label, metadata on the edge, which could help do layout stuff, and some overall metadata. There's some kind of iteration down here where we talk about it might be more consistent if for these vertices, excuse me, meta was another key under the map, because for edges, we see we have an explicit meta key, and for vertices, it's just implicitly that map there. I tend to think that's a good idea to make the structure, make the structure more explicit. So I think this kind of representation is nice. Everything's explicitly always under a meta key. One of the things, kind of aside, that one kind of misses going between EDN and Clojure you can actually attach metadata to, like true metadata to things, but also that doesn't actually work if you're trying to write things out as data. It's unfortunate, perhaps. And then also talking about using namespace keywords makes it a little more like future-proof, a little more flexible, because people can stuff arbitrary things in there. So yeah, I think this is a good, like, kind of reasonable representation of a graph in Clojure. Pretty straightforward, but we can leverage kind of some nice Clojure things to make it easy to extend things onto it later, having like namespace, having like meta maps. Do you have anything you want to add for that?
Yeah, so one of the things I often when I'm trying to do these things is, and in general when programming, is whether, like for example, looking at the from and the to on an edge, like part of me just wants that to be a vector, right? And I'm wondering if like it could work, for example, where edges was a map where the key was a vector of from to, and then everything else was a map afterward. I mean, it could. I mean, and it might be. It's one of those things where, like, it could be useful, but maybe it's harder to parse. And probably the first thing that I would do if I was actually like writing an interpreter for this was to convert from that like more abridged syntax to this kind of more just like literal, just like lists of maps type syntax.
I guess it also depends like what you're doing, right? If you like, this is kind of explicitly, then we're talking about like a digraph where you have like a directed graph. Whereas if it was an undirected graph, then the from and to maybe isn't quite as clear.
Yeah, but you could do like a set in that case, where if it's like, if it's non-directional, it's just you do the key is a set of ID to ID, and then the value is some metadata around it. I think it could work. I think like it's this thing where like you're trying to balance a little bit of ergonomics on the human side, and that's really hard. Like you really need to like go through a lot of example use cases to figure out.
I was going to say, speaking of ergonomics, like one thing that occurs to me, like it's nice to have vectors or sets, but then that would kind of lead to like, okay, what if there's more than two things in there? And like, if we allow more than, if it's one, okay, it's a thing back to itself, that's fine. But if it's if we have like more, if there's more than two nodes, it's not really a graph anymore. It's something kind of a little different.
Yeah, and so like that's where like the bounds that you choose for one of these things, like the scope of what you're trying to do makes a really big difference. And so I think it eventually comes down to like, what is your problem case? Because if you choose a more specific scope, you can start making those kinds of decisions. Like if you're saying, oh, there's only ever going to be one relationship between, and it's always going to be directional, then your API is going to look a little different than if you want to support more general cases. And in that case, it ends up usually being a bit more verbose. And yeah, so the scope defines the choices that you get to make. And sometimes it's a good thing and a bad thing. And I think that's like where sometimes it might be more useful for you to do something at a smaller scope because the ergonomics increase. And so suddenly it becomes a much more useful library potentially, but sometimes like it really depends, right? But sometimes it's better to be more general so that there's more use cases at the cost of not having that big of a win on ergonomics. But cool, good stuff.
Let's move on.
Yeah.
Cool. So the next one is a DSL for parsing byte arrays. This is neat. I think like, this is a useful thing to have. I know there's some languages where it's very easy to parse like binary data. Like Erlang has its binary things, Prolog similarly. If you're doing like parsing protocol stuff, it's super useful to be able to have like high level things. I think, yeah, definitely a neat thing. I think that would be useful to have. I do like this declarative thing. The first thing that comes to mind looking at these things is I kind of feel like there should be more of a duality between them. Like, so I think this makes sense, kind of encoding the operations, or you can say, like, the first thing in this vector is like the operation, then it has some arguments. So, reading a 32-bit integer, we say it's big endian, reading a string where it's so many bytes encoding is UTF-8. I guess we're assuming, presumably this has to be bytes, not characters. And reading on a 64-bit float and big endian, and then it could give you a vector like this. Then we have a write. The first thing that comes to mind is like, is there some way you can like unify these things?
Yeah,
Not
like
to
because
kind of-
it's just like
yeah.
you can just declare like this is the structure, and so in theory, yeah, you should be able to have one
Yeah.
way of saying like the bidirectional.
Yeah,
way
one,
of
you know, maybe
describing it.
a backdoor plug for my talk, the videos there is kind of is about a prologue. And one of the things that, as I mentioned, like parsing this kind of binary data in Prolog, one, it has this built-in like basically parser syntax called DCGs, which is really nice. One of the really cool things is that you can write them so they can run both ways. So you could essentially write like a declarative parser and use it for both reading and writing. And like it's a thing that I really like, because if you know, assuming that this is the same kind of data, we're kind of duplicating a bunch of work. Off the top of my head, looking at this declarative thing, yeah, so suggestions, instead of saying read, we just say this is a 32-bit integer in this format. And then that would, you know, either read if it's in reading mode, or like would take the next thing to output. In that case.
I was thinking like in the case of writing, right, if you just had like one schema for this type of thing, then your writing function would take like the schema and then just like a list of like, for example, 41
or even I was thinking like if you have like a
bytecode.
map, right? If each of these things, maybe the first argument is like a key that you want to put this thing into, or like nil if you like for the things where you just drop them. And then for the parsing, instead of a vector with this implicit order, it would give you a map of all those, like the result of all those readings. And then for writing, you could use that same structure and just give it that same map. And this would say, okay, you know, 32-bit int with the key, you know, header tag or whatever, and then it finds that the thing under the key header tag in your input map.
Yeah,
and so
yeah, that's cool. So it's kind of like regex matching groups, but named matching groups.
Yeah, and then you could also use it in reverse to like, given here are the matching groups, generate the like input string.
No, but in general, I love this like choice of problem, because it wasn't on our list, and it is a great one. I really like it. The other thing I was going to say is like you might like look at Molly maybe for maybe similar syntax for like how to potentially do the like options versus keys versus like.
I can see if I mean, super quickly, I can see if I can pull up transit.
The protocol that your transit.
Is what it is. I mean, this is going to be pretty old.
Well, we just we'll post it in the.
Yeah, I'll post a
Slack
link later.
Yeah.
The thing like it's doing a similar thing where it's parsing transit, with Prolog, and it has to do a bunch of stuff that's ranch like this. So I'll post it maybe later if people are interested.
Oh yeah, that's really cool. Great job, and I think people would use it. I mean, with a few tweaks there, I think there's some potential because.
Yeah, no, as I said, like, I use a very similar thing a lot, and it's super handy in a lot of cases. Yeah, very cool. Okay, so this next
like
one
I could see actually good. Last thing I was going to say about that, like I could see something like that being used within, like as an extension. Like people would use it either with spec to spec out something within a data structure, like because basically you're trying to spec out like a complicated list that has some special rules. Anyway, very cool.
Cool. Okay, so the next one was making declarative DSL for Gherkin. That defines like the behavior stuff in these tests. So we have essentially just encoding this thing into a map. And then the step will be matched with a step type. And then the text. So then you'd have, I see. So then you'd have these separate handlers with the step type that corresponds with the key in the step, and then it receives the context as a function, receives the context, and does something. One thing that comes to mind looking at this is I feel like it might be easier to have like separate keys. I mean, it does read a little nicer with the key being like given and then. I would maybe think, would it be reasonable to have like type given and then like step and then being the string. I guess there might be a lot of duplication, but I just find it can be somewhat annoying if you have a map where you care about what the key is, right? If you're trying to distinguish based on different keys, I find like that can be somewhat problematic. Maybe if it was like a vector or something like that, where the first thing is the type and the second thing is the string. I wonder too if we could kind of expand these strings out. If like, is there a reasonable like data representation of what the string is that we could do, like kind of datafy that in some way?
Yeah, I think in this case, like, you know, this is like a one-to-one approach, and I think this could be useful as a way of like, hey, I write my I want to use Gherkin, like the underlying actual like Gherkin library, but I just want to write stuff in Clojure because I might want to generate stuff in Clojure and stuff, and so that would definitely probably work. And so trying to keep it as one-to-one could be useful. But something else to try in with some of these exercises is that, like, you know, given now that you are doing, let's say, things in a data-driven way, how might you completely like reframe the problem? Like, would you do things in a completely different way if you didn't have to talk to Gherkin, the library, and instead wanted to come up with something of your own? And maybe there's something there. I mean, I'm not saying that I have an idea of what that would be in this context, but there could probably be certain things that you might be able to do. And this is a library where, like, part of me is like, is it better as data driven, or is it better kind of as a fluent one, where kind of how like testing is like in Clojure.test, right, where you would do like a scenario, like where scenario would be like bracket scenario A, and then you just give it steps given when then would all just be functions. Like, it's something, it's hard to say, right, whether that would be better or not. And I feel like a lot of the fluent ones, what they tend to do anyway under the hood is like all those functions, they just like, well, some of them might be macros, but some of them might just return the underlying data, but it just sometimes is nicer to work with. Yeah, but
yeah,
this is looking interesting. Yeah.
Oh yeah, so here we have our like XSLT for EDN, pretty neat. So given some EDN data structure, oh, refresh, oh cool, I'm told there is new stuff here. Is that good? Cool.
Yeah, I saw it. I saw it change.
Yeah. Okay. Yeah. So we have our data, and then transforming it in some arbitrary form. And we also see turning it into like HTML. And so we have the equivalent of XSLT like style sheet. It's pretty neat. So I have a sequence of keys where I guess TPL is just like template. But we have anyway some like special key here. There's XDI namespace that indicates, I guess it's like when you find this key, this is what transformation to do to it. And then it looks like it kind of will recursively go through the thing it's given. And when it finds a vector that begins with XDN apply, then says apply the corresponding transform to like the things under this, I guess. And then for the kind of the leaf values, like this person map here, corresponding to one of these, I guess, we can have to get a value out of it. And then it looks like we can also specify a function that will then just get that value and do arbitrary things. This other example here of doing this with HTML, where the outer ones are saying we essentially have one thing where it's a list of persons, and then it applies the person transform to all the things under it. And so each thing is like an LI, and then it pulls out the person's username. And then again, we have like an arbitrary function that gets the whole person object and does some transformation on it. Oh yeah, we have down here. So yeah, and we have kind of some documentation here. So template would like name what the path is in the EDN. You could also give it a vector of paths, which is neat. And then we can, we have the template, and then we have, value, which is like the value, I guess, at that point that we kind of navigate to. And then this is for doing, I guess, finding other nodes in this graph. So yeah, this seems very neat. This seems like it's kind of like a declarative version of Spectre, I feel like, in some ways, like Spectre select, I guess, transform of like doing kind of this arbitrary traversal of a data structure.
Yeah, no, I like it. So from my point of view, I wonder whether that XD and TPL at the beginning is necessary, or whether this could just be like a map of keys to match on to values. But again, this is just based on like thinking about this for 10 seconds, so you might know better. And I know that when we were chatting in the thread, you have a lot more experience with XSLT. But again, like basically, you don't necessarily have to follow all the conventions of like XML. The other thing I was thinking is whether there's any opportunity to make use of, well, I had mentioned Spectre and you had mentioned it as well, but alternatively, it's using equal. Because like if we're assuming that we're operating on graphs of data anyway, then the EQL query spec might be useful.
Yeah, I guess, yeah, it's almost like, the equal or like pull syntax, but just with like other, being able to put like arbitrary other stuff around what you're pulling out. Yeah, that's neat. I'd be curious to see, like, as things start getting bigger, how like these things like XDN apply might work or might get more complicated. I'm wondering things like if you only wanted to render people that, employee is true or something like that. If you want to do some kind of conditional rendering, or if there's like different types of values you could traverse over. It would be kind of interesting to see how weird this would become. I mean, I guess XSLT stuff gets fairly complicated.
Yeah, I could see using this. I mean, this also reminds me a bit of, what was that library for like doing template manipulation in like as an NLive, was it?
Yeah.
Yeah. So there's a Clojure library called NLive, which also does a similar thing in some ways that might be worth looking at as prior art. And so it does it using like CSS selectors, I think. I mean, it is a lot more.
But I think examples, but yeah, whatever. It's like a similar sort of thing where you have like the HTML, and then you specify like transformations that you want to make on it, and like generate code. Yeah, so it's more of like you'd have your just like your HTML just written as like normal HTML, and then basically do XSLT on it, but with Clojure. Like you can be dynamically creating the transformation. So yeah, that seems you could do this sort of thing with Hiccup, like using this. You could do that sort of MLive style transformations, but having your HTML's Hiccup instead of HTML.
Cool, nice, good job, awesome.
Yeah, very cool. Okay, the newest one. Yeah, so this is the we have an image, very nice. Yeah, the DSL for making command line arguments. So like, what is it, like GetOps kind of thing? Yeah, and I think this can be a very straightforward thing of just like the flag, and have an optional full thing, the help that will run, coerce. I'd almost want this coerce to be a function instead of a string.
Yeah, I think I mentioned when we were chatting on the Slack thread, I mentioned you might as well just, lean on Spec or Molly and their existing coercion systems there. And that way people can just like use specs for like, effectively that specific part of it is a solved problem that you could just borrow from, I think. Because like those, I imagine those could be kind of semi, like, some of them will just be int or whatever, but I imagine some of them might be like, oh, you're passing in a string that has a certain format, and so you might want to, or like, this argument is a JSON document or whatever, and so it might actually need to be somewhat parsed.
Yeah, some other things that might be interesting too would be like, if you start getting like pathological, it's like if you have mutually exclusive switches, or like a switch that you can have like -- no foo or -- foo or something like that, like enable or disable it. Like the difference between flags that are just like binary and flags that take an argument.
Yeah, so so having a key called like exclusions, or so for example, --foo would have a key as well on it that says something like excludes this other one, or must exclude or whatever, or it could also be like must also include, because sometimes you have arguments that require, like this argument only makes sense if this other argument comes in. Now,
Yeah.
in the general case, that can get really, really complicated. Like, oh, well, you can have any two of these, but only if you don't have this one. Like, that probably isn't a case that really needs to be handled in general. But yeah, this is cool. I didn't know this existed, but someone posted that there is a Clojure tool CLI that exists that does something similar to this already, just for reference. But yeah, no, this looks like a and I guess can you pull that up, James? Can you just search like Clojure tools CLI, just so that we have so we can compare some of their approaches that they took.
Tools.cli.
Yeah, the first results. And so yeah,
okay,
so there
yeah,
we
so pretty
see
similar. So
here they choose to instead of having a map, they kind of do a slightly more abridged syntax by just having a vector of like various things. I feel like at this point it's like almost a map anyway, and so I think
I assume they're turning the rest of it into a map, but this is like the first ones to keep it concise, I guess.
Yeah,
which I think can be reasonable in like a sort of data-driven thing.
Yeah, I think sometimes it works out, sometimes it doesn't. I just feel like even though doing the full map is slightly more verbose, at the end of the day, like I don't want to have to looking at this. I don't remember what the second why is there nil there, right? Like what am I nilling out? I'm gonna have to look at the docs to figure out what I was just nilling out. And so I find sometimes being a bit more verbose helps for clarity in the future. Basically, I try to write code.
I would almost think like
Sorry, I was going to say I like to write code to be as generous to myself in the future as possible, because I assume that I don't want to. Well, I want to assume that I don't have to be on the top of my game when I read this code in the future.
I was going to say, if you really want to get fancy with it, is even if you had it be like a vector for these first 3 things or optional 2 things, and then you could just use metadata to attach this other stuff as a map. It does make it read, I think, a bit more awkwardly if you do the inline syntax, because then the options come before the thing.
Yeah, I find meta sometimes.
Yeah, I mean, it can be awkward, especially for printing it out. Yeah, I do like to. They have like an ID, so they indicate like what the key is going to be under. I guess.
So this is probably
not entirely clear here. It's just like it's doing some defaulty thing where if there's a long flag, it gets it from that.
So this is similar to what we were talking about with the parsing the binary data, where like by putting the IDs there, then you know what you're going to get out. Like you're basically naming these capture groups, which is cool. All right, let's move on to the next one.
Where are we now? Grills. Oh yeah, so representing music here, and I'm putting this in some reasonable format, which I'll say that I know nothing about this. So your sort of measures. I'll assume these are double quotes. Output. I do not know what a grills chart is, but I'll assume it's some sort of music.
Something domain specific. You know better than us, John. I mean, I think on the first glance it looks pretty reasonable. I wonder if it's easier to sometimes even use keywords. I see some libraries sometimes instead of using strings, they'll tend to use keywords or make it optional, like whether you use a keyword or a string for any one of those things. Just because it's one less letter to type, you don't have to close it. But like Garden does that, and I quite like it, where like your selectors can be keywords, but then certain things can't fit into keywords, and so you have to use strings in those cases. But
yeah, one other thing, I'm assuming is each one is each one of these lines a measure. So I would probably prefer to have like the nested arrays, like nested vectors here. Yeah, I thought about keywords. Yeah, I mean, you could also just quote the whole thing. Each single symbol is a measure. Okay, so the wrapping is just for formatting. Cool. Okay, that makes sense then. Yeah, I'm wondering if there'd be any point to like decomposing the measure more in some way. But I guess it is like somewhat like an atomic thing for what we're doing.
Yeah, and it's like basically now you have another micro DSL. You have another tiny little like syntax here for, you know, within like what each of these strings represents, the % sign versus the other.
Yeah, and as Max is saying, you could just quote the vector to make it work. So yeah, maybe then they would just be symbols instead of strings. That could also be nice to write.
Yeah, the only catch that I find with those APIs, so like you see that in like Datomic, where they'll use the quote, and that way you can use symbols within a list, and that helps, you know, even less characters. You get to like less characters to type. The only challenge when doing that, I find, is then it makes it tricky to generate. Like you can't put a for loop in there anymore if you're trying to like write code.
Yeah, so it's like, you know, like Datomic has like the separate way of passing in like queries that or passing in arguments that you now need, and inventing your own like argument passing system. But there's only something like this where you're just like, actually, yeah, I guess it couldn't be kind of awkward to generate. Although there's nothing that says you have to do it with a quote, right? It's just a convenience.
Yeah,
you could, if you want to build that vector in some other way. So yeah, this makes sense to me. So we have chorus, and presumably you could have like other things for other types, like other parts of the song. I feel like I don't really know enough music to chorus, intro, outro. Presumably there'd be some ways to indicate like, well, I guess I wonder, is it useful to have more ways of representing repetition? Like, is the % here indicating like same as previous or something like that, or like rest?
Anyway, so this, like, before we move on to the next one, I wanted to mention how like there was I recommend you guys look at the Slack earlier in the workshop. There was a pretty good discussion started about like what makes a DSL versus just some data notation, because like this, like, is this a DSL or is this just a way of representing stuff? And we kind of said, like, you know, the line is kind of blurry. I don't really have an answer. And I think sometimes like what definitely makes it feel more like a DSL is when the thing that you're writing implies some sort of behavior. So like with rate, right, there's a matching and a choosing that, like, basically the system you're passing it to is going to have behavior. Whereas for some of these exercises, we might have not, like, there might not be any implicit behavior. But that's okay. I mean, I think it's a similar exercise in terms of just trying to get notation down. But the moment that you, for example, took, you know, with this music one, said, oh, okay, well, the interpreter is going to now, you know, given this, it won't just like print it out or do something else with it. It will actually like play or in different ways, or it will actually have some behavior, and then it's a DSL. Maybe. I mean, again, it's these, but it's an interesting discussion there that I recommend people look at. Okay, we have 3 more minutes. Let's go. Maybe
we have 3 things left, so if we can do 1 minute each, I guess. I'm sorry that we're having to move up, but I mean, yeah, this looks like a pretty reasonable DSL for doing like 3D modeling. Reminds me, I believe there's a talk on like the dactyl keyboard. The fellow talks about using a similar kind of Clojure DSL for doing 3D modeling, so you can represent like intersections of hulls and stuff. So you have like type union, and then presumably you could like combine these, nesting them in different ways. So you have entities keys repeated, so something like this could within it have another thing that is like an intersection with some other ways of representing things. So we have kind of type as like sphere and cube is somewhat atomic.
The way I've seen, I played around with doing this was actually trying to mimic the hiccup syntax, because you could think about like union could basically be like the beginning of a vector would be union, and then it would just have children. And if that union function had parameters, then it would be like union, curly brace, some parameters, and then children. Similarly, when defining a sphere, it could be like vector sphere, and then parameters, and then if it had also had children.
I mean, because that lends itself well to having like custom types of entities, because you just have like a function or some other arbitrary keyword.
Yeah. But this works too. But I think there could be a very hiccup-like version of these like nested children with options as a general concept, and then basically a hiccup for 3D. Try it. And I like that you've provided
yeah,
Fluent.
compare with the Fluent. I'd say use that as like with an OpenGL backend or something. Let's do 3D graphics. And so this is playing Dominion. Nice. With Clojure, so the Dominion card game.
So representing all of the cards, yeah, because the cards can get quite complicated. Neat.
Yeah, so we have like cost. Here it's a coin of a certain amount, the actions that it takes. Like, yeah, they're trying to come up with nice ways of encapsulating what happens with the from. So again, trying to do this without functions, trying to represent declaratively what happens. This is a pretty neat. I think this is very neat, and they're talking about having some way of like capturing what star refers to. So in some way, it's kind of like parameterizing. Everyone's the best card in Dominion, obviously, the seller. You trash all your copper.
Yeah. This makes me think like I didn't, I had mentioned, oh, why don't other people do data-driven stuff? And what I forgot when I was giving my talk was there is a certain subset of people outside of Clojure that definitely does a lot of data-driven stuff, and that's video game folks. Because like, if you imagine someone implementing Dominion as a video game, I mean, I'm sure there's an object-oriented solution, but I would imagine that a lot of them also are based on stuff like this, because it's the only sane way to like manage, 300 different cards that might exist in the game. And so I think that they might not talk about it much. I think like entity component systems is the technique within OOO, but I think you could do similar things. Like this kind of approach could be really useful as a way of defining like your data model for like this game.
Yeah, it's 3 o'clock now, so I don't want to run over time. I'll say, I think this is very neat. I think as they've identified here, kind of one of the challenges, like some way of like capturing some bit of data that maybe has some sort of like dynamic dependencies on these things. At least like the actions, because they're a vector, they're like ordered in some way, so you could presumably have some ways of encoding like implicit actions, like the first time a star appears. Could even be something, as they mentioned, data log, having like question mark cards where the first time it's encountered it's bound, and then subsequent times it now has to match that value.
Cool.
Yeah.
All right, let's not run into,
cool.
There's something happening right at 3, so we've already gone over time. Again, thank you guys for participating. Sorry we can't get through all of your things. Hopefully this was valuable and enlightening. Let us know if you have any feedback, either via direct message or in the Slack. But yeah, keep playing, keep iterating, keep tweaking, and thank you guys for participating. This was great.
Thank you so much, everyone.
Awesome. Thank you, guys. Thank you, James. Thank you, Raf.